Good morning, everybody. Thank you, Jane, for your kind introduction and for the invitation to this exciting workshop. In the next 20 minutes, I try to give you a short overview about the point of view of Volkswagen Group's research about automated driving vehicles. I will start with a short motivation, followed by the status of Volkswagen Group research. And afterwards, I will show you a few introduction scenarios for automated driving vehicles and the definition of terms according to the SAA working group, followed by, this is more or less the focus of my talk, future challenges for high automated driving and finalizing with a short conclusion. Why we are focusing on automated driving? So we have at least 6 good reasons for doing so. The first one is we have this challenge. We have to reduce emission of CO2, and here automated driving can be beneficial. Using a predictive driving style. Another challenge is the demographic change, of course. Here we can support unconfident drivers, and we can enhance the mobility of elderly people. Third, we have this vision zero. That means we want to avoid accidents. With automated driving vehicles, we see a potential for more driver support by avoidance of human driving errors. In other words, we will avoid accidents. And then we can increase the traffic. The next challenge is the increasing traffic density. We are expecting more traffic jams, for example, and we can avoid this by the optimization of the traffic flow. We can offer to the driver a convenient, time-efficient driving via automation. In other words, we allow our drivers to do some secondary tasks. Economy is an important issue, so we ensure our unique selling position in the future by developing these new technologies, and we offer attractive products by technological leadership to our customers. And last but not least, the maturity of current driver assistance systems. So we have sensors which are approved and cost efficient, and we have actuators in series production. So this is a difference with respect to the situation that we had 10 years ago. So if you are now driving a driver assistance system like ACC or lane keeping in combination, then you really can experience that we are close to the border or we are at the borderline to automated driving. So automated driving, is it safety? Is it comfort? It's both, is the answer. What we are selling to the customer is comfort. So imagine you have a traffic jam pilot or something like that. So you allow the driver to read newspapers, to do some texting or something like that. Of course, this is the comfort, this is the sugar, that is what we are selling to the customer. But enabling this is based on a mighty technical platform. So we have sensors on board, we have computers on board, we have actuators on board, and of course all those are available even if you are, for example, in a city where you can drive automatically. And on the basis of this technological platform, we can realize safety functions like emergency braking assist or pedestrian protection and something like that. So finally, the message is developing and selling automated driving. We also enhance the introduction of driver assistance systems in the market. And this is a good reason for doing so. So the status at Volkswagen at the moment, we have a huge number of driver assistance systems on the market right now. I don't go through all those pictures one by one. So the message is we have lane assist, we have ACC and other systems like that. So the technology for automated driving is partly available, and this is a very good starting position for a research guy like me. What about the research activities at Volkswagen Group Research? Actually, they started even in 1919, but really the starting point was the Grand Challenge in 2005. There we had this fabulous cooperation between Stanford University and the ERL. The ERL is our research facility located here in Belmont. Yes, finally, our Stanley did the first place and is standing now in the Smithsonian Museum. This was really a stepping stone in the history of automated driving. One of the next big projects has been, of course, the DARPA Urban Challenge. Here, our junior, again, the cooperation between Stanford University and the ERL was quite successful. We took the second place. In Germany, we showcased our Paul. The functionality is a kind of key parking. You just step out of the vehicle, push a button, and the vehicle is doing the parking maneuver by itself. Another project has been an Audi TT in 2010, where we climbed the Pikes Peak autonomously at the dynamic limits. In Europe, we have presented our temporary autopilot, TEP. It's finally partial automated driving in a highway scenario. And in 2011, we have presented ET, electrical transport mobility vehicle. The use case is, so there's the postman delivering the post, and he has his sack around the shoulder, and the car is following him. He's just pushing a button on his iPhone or something like that, and he's standing outside the vehicle and the car is following. That's the showcase. So what about an introduction scenario for automated driving? So here you can see the definition of terms according to the SAA draft. Taxonometry and definition of terms related to on-road automated motor vehicles, which will be published soon. I will go not into the very details of it, just some comments from the customer perspective. Well, we have that partial automation on the left side of the red line. Here you can take the hands from the steering wheel and the feet from the gas and the brake pedal, but you have to monitor the traffic, the surrounding vehicles, and if something happens, the deer's jumping on the road or something like that, you really have to react on that. And you are not allowed to do any secondary tasks. And then we are crossing that borderline, here the red line, which is really a borderline, and we allow the driver secondary tasks, not each and every secondary task, but specific secondary tasks. That means the driver, when a takeover request occurs from the system, then the driver has to react within, let's say, 10 seconds. So you are doing your texting or reading your emails, then a takeover request occurs, you push your computer to the side and take control of the vehicle again. High automation, that means you are now also allowed to sleep. That means you take overtime increases, 10 seconds, not 10 seconds while you're sleeping, 10 minutes or even more. And the ultimate scenario is full automated driving. Then you have a robot taxi or something like that. That means it really drives you from origin to destination. What are the future challenges for automated driving vehicles? I really love that picture. Because it reflects the position of one of my colleagues. So all those talk about automated driving, we have ACC, we have lane keeping, so where's the problem? Unfortunately, there are some problems, so we don't need a miracle, but we need some activities. One of them is we have to work on learning map and online services via vehicle-to-infrastructure communication. Here's depicted on the left side the current status concerning digital maps. So the up-to-dateness is bad, it's months or even years, and the level of detail, that means the accuracy of the radius of course or the steepness of the road or something like that is quite bad and not very accurate. And if we want to build even driver assistance systems on those maps, we have to increase the up-to-dateness to days or to months or even days, and even the level of details to medium. And for automated driving, we have to increase the up-to-dateness to days or even hours, and the level of details has to be increased to high. Concerning vehicle-to-vehicle communication, so there's a lot of talk about that topic in the scientific community. So here just an example how to solve that hen-egg problem with vehicle-to-vehicle communication. In Germany, emergency vehicles will be equipped with vehicle-to-vehicle communication technologies, so that the customers, the very first customers buying those technology, they will have a benefit from that. Release testing hasn't been mentioned yet, as far as I understood, which is really a big topic. So here's depicted a typical scenario for the release testing of an automotive product for software. At the very beginning, you start with some software modules. You test those software modules one by one, and afterwards you combine those software modules to a greater software module, and to test them in a software-in-the-loop test, and then you integrate all those modules into the hardware, so you have those electrical control units, and they will be tested in a hardware-in-the-loop test. And afterwards you combine those, or you put those ECUs into the vehicle, and then you test drive those vehicles. And at the bottom of this rectangular, so the test depth is quite good, but the more components you are integrating, of course, the test depth is lowering. And what will happen in the future if you increase functionality, if you increase the number of software modules? So, of course, you have to do more testing with respect to software modules, software-in-the-loop and hardware-in-the-loop testing, but unfortunately also the vehicle testing increases dramatically. And it is foreseeable that it's getting to a limit where we don't have a business case from the OEM side because it's too expensive. There has been some studies, and they expect about 100 million kilometers that have to be test-driven, and this is far too much. The solution, we need an intermediate layer here. We call it virtual test drive. So finally, that you shift test kilometers from the road to the computer, and this might be a solution. Another issue are, of course, legal issues. So the problem is simple, but the solution is complicated. As I mentioned, on the left side, the driver is still in the loop. He has to be attentive. And here we have no significant change with respect to existing driver assistance systems. We have to adapt some ECE regulations, but we can manage that. But if we are on the right side of the red dotted line, we take the driver out of the loop, and that means that is not in accordance with regulatory law like the Vienna Convention or national road law. And we have there an extra risk with respect to product liability for the OEM. And here is really a need for action. Concerning legal aspects, there's a working group in Europe from the Association of Vehicle Manufacturers. You will find the members in the first line. So the objective is we are creating the framework conditions for the establishment of automated driving functions, and the focus is on definition of terms, as done in the SAA group, for example. And international homologation regulations like ECE regulations, and last but not least regulatory law like Vienna Convention and the German Road Traffic Code. All these regulations have to be changed, and we support that. Another issue, driver state monitoring. So why do we need that from the legal perspective? So here, naive picture to explain the difference between intended use, unintended use, and misuse using the example of the chair. On the left side, you can see the intended use, somebody sitting on that chair. Check. Unintended use, somebody standing on that chair. Of course, the chair is not designed for this use case scenario, but imagine if that little children breaks through the chair, is injured, and you are standing in front of a judge and in front of a jury. Who will be blamed? The chair manufacturer, for sure. This situation changes if you have a clear misuse, so you clearly overload the chair with heavy weight, and this is a clear misuse. So nobody will blame on the chair manufacturer if the chair breaks. So this is a funny picture, but for products, we have to take exactly that into account. If you take the example of a lane assist, the intended use is the driver has his hands on the steering wheel. The unintended use, the driver has not his hands on the steering wheel. We have a technical countermeasure for that. So we have a hands-on detection in our vehicles. And the misuse is, yes, you are cheating this hands-off detection with some mechanical stuff. And looking a little bit into the future, we have a traffic jam assist, which is partial automated. That means the driver is in the loop. He has to be attentive. Unintended use is the driver is not attentive. It is, and this is quite foreseeable, that we write into the user's manual, yes, we have to be attentive, but he will not be attentive for sure. So that means we need technical countermeasures. So, for example, driver attention monitoring. You may imagine an emergency switch or a camera to detect the actual driver state, if he is attentive or not. A clear misuse if you are cheating the driver attention monitoring using a mask or a puppet sitting behind the steering wheel or something like that. And looking at conditional automation, that means specific secondary tasks are allowed, except sleeping. Then, of course, the unintended use and foreseeable use is, yes, the driver will try to sleep, and we have to prevent that. Again, via driver monitoring. So, for example, we need a camera which detects whether the driver is sleeping or not. And again, clear misuse if you're cheating this system with a mask or a puppet. Last but not least, failure tolerant system architecture. So what does that mean? So imagine we have a technical problem, so a sensor goes blind or a computer fails or something like that, and take over request occurs, and the driver doesn't react to that. So what happens? So will the vehicle drive into the guardrails or something like that? No, it will not. We will perform minimum risk maneuver if we are talking about high automation. So the vehicle is driving to the hard shoulder of the motorway, for example. The maneuver will be designed like this. The takeover request occurs, the driver does not react, so we intensify the takeover request. So at least we are doing also a short, sharp brake as a haptical feedback, so the driver doesn't react. So we start the lane change maneuver, we activate the hazard lights, for example. We are driving the vehicle automatically to the hard shoulder, and we will bring the vehicle to a standstill, activating an e-call and activating the parking brakes and unlocking the doors. So because imagine the scenario, you're on a highway, we did all those driver information and steering maneuvers, and the driver does not react to that, so obviously there's something wrong with the driver. Some medical problem or something like that. So this is the reason why we activate here the e-call. But here the driver is always capable of overriding the maneuver. This is important. So if he wakes up or something like that, he can always intervene. What does that mean with respect to the different degrees of automation? So here a scenario, you are entering a tunnel. In the tunnel you have a component failure, sensor goes blind or something like that, and an automated stop on the emergency lane is not possible for several kilometers because in the tunnel there is no emergency line, for example. And you are surrounded by a fast-moving, dense traffic, so a standstill in the tunnel wouldn't be safe. So what will happen? For partial automation, where the driver is in the loop, well, a takeover request occurs, and the driver has to take over within a second or something like that. So that means we don't need any extra capabilities to keep the system fail-safe operational. For conditional automation, for example, a highway pilot, we have to maintain specific system capabilities like distance keeping, lane keeping, speed adjustment, or emergency braking. But for conditional automation, the system survival time is only 10 seconds. So he's reading his newspapers, the driver, takes it to the side, and then takes over control again. This takes 10 seconds, something like that. And now imagine you have a high automated system. That means the driver is allowed to sleep. He gets the takeover request and then needs several minutes to wake up. And therefore, the system survival time is maybe a few minutes, a few 10 minutes. And from the technical perspective, the technical effort between conditional automation and high automation is that for conditional automation, the technical effort is even high, and for high automation, it's even very high. In other words, conditional automation is not so expensive than high automation. And looking at an introduction scenario for automated driving system, conditional automated driving is an important intermediate step which cannot be neglected. Okay, you can find the conclusion in the internet. I want to say thank you for your attention, and if you have any questions, please don't hesitate to ask.
Please, questions.
So a couple questions. First, everyone is talking about their level 2 systems, the hands-off cruise control. Is that going to be all that good?
Excuse me?
Is that going to be all that good? Is that going to be all that exciting, a hands-off cruise control?
Is that exciting?
Yeah.
I think so. So you're
not exciting in a bad way. I mean exciting in a good way.
So you're talking about partial automation, where the driver has to be attentive, but maybe he's allowed to take his hands from the steering wheel. Well, it's a similar scenario as it is for SEC. It's hard to explain if you haven't experienced that.
No, I like the cruise control. It's nice.
Yes, it is. Okay, agreed. And if you have experienced that you are allowed to take the hands from the steering wheel, so that you don't have to do the lateral control. So ACC is you have to do the longitudinal control, which is sometimes a hard job, and you are lucky if you are released from that job. And finally, it's the same for the lateral control. So if you don't have to do the lateral control and you are allowed to take the hands from the steering wheel, it's more comfortable.
Now, something more technical. On your previous slide, you talked about the capabilities that needed to be retained in the event of a handover event, such as retaining distance keeping and lane keeping and so on. But you had described that when the driver didn't respond, you wanted to be able to change lanes and get off of the road. So you need to maintain more than those capabilities in that situation. You'd need to maintain enough perception in order to change lanes and to get off the road, would you not?
So finally, you need redundancy. So if you have a sensor to measure the distance to the vehicle in front, and that sensor goes blind, and you have to maintain that capability, you need an extra sensor.
Joe Peters.
I would suggest that in the amusing presentation you gave, you've encapsulated many complicated things in very simple ways to understand. One of those simple things was the miracle occurring. And I would suggest that that miracle is occurring behind closed doors, and it's occurring in a place where people don't want to talk about them because of that. I see a trend in this discussion about being risk averse, but there's the benefit side of that. And so my question is one whereby, from a person who has been driving an adaptive cruise control system for many years, I've very much attuned to the problems with that. So my question is anybody looking at any kind of learning techniques of what gap acceptances are for drivers? I mean, the big miracle is overcoming individual differences among millions of people. And how do you accommodate that? I would think would be through some form of adaptation to the ability of the driver.
So if I got your question right, is what about self-learning algorithms for automated driving vehicles? It depends, is the answer. If we have self-learning algorithms that are transparent, so that means we know why they are doing what they are doing, they can be accepted in automotive industry. So, but if they are black boxes and we do not know what they are doing, they can't be accepted.
So the answer is there are things going on behind closed doors to sell cars. Is that what I'm hearing? Is it that there are things going on behind closed doors, even though this is a difficult problem that people, I mean, it's not being discussed in any forum here, and I'm just amused at that. It's apparently not an issue.
I'm not aware if that topic has been really discussed into details, the pros and cons. What I can say that there has been research work in the past, also together with universities, with respect, for example, with Bayesian networks. So these are gray boxes, and then they can be used in automotive industry. And yes, in Germany we have a lot of cooperations with the universities working on that subject.
Thank you.
Greg.
Thank you for your presentation. It was very insightful. So you talked about as automation complexity increases, there's going to be, you made a case for simulation to support vehicle testing. And my question is, do you have any insight on whether it will be possible to detect and measure unintended consequences and misuse through simulation?
I will talk about this topic in the afternoon, in the breakout session. So finally, the question is, if we do our testing, is the test catalog complete? Do we really think about all thinkable and possible scenarios? And this is really hard. Even for an ACC system, we started to write down possible scenarios, and we ended at 3,000, something like that. 3,000 only for ACC. And imagine you have an autopilot or something like that. There will be several 10,000, and challenge is to be certain that this test catalog with this huge amount of different test cases is complete, and that we didn't have forget any relevant use case. And this is really a challenge, and here I see also a research need. At the moment, I'm not aware of any method which guarantees to have a complete overview of potential use cases.
I just want to add, I want to plug the human factors breakout session because we will be developing a research needs statement on that issue. So.
Okay.
Our last question from Maxime.
Thank you for the very good presentation. You mentioned, and the previous speakers mentioned also online map data. My question is Volkswagen and eventually others going to also going to be new actors in terms of map data, or are you relying on the traditional industry?
Again, I would like to mention the breakout session even in the evening. I will go in some details about that topic. Finally, we have a huge car fleet on the streets with a lot of sensors on board, able to detect lane markings or something like that. And of course, this is an opportunity to increase the up-to-dateness of maps. And yes, we are working on that subject.
But is that in collaboration with the mapping industry, or is that going to be new player, new competitive?
If collaborations means we talk to each other, yes.
Thank you. Thank you very much.